Hello and welcome to math. Today we will learn about the real number system. Hey, good morning, everybody. So today we're going to learn about the real number system. Here is a Venn diagram that we're going to be learning about for the Venn diagram for the real number system. But before we move on to the real number system, here is like how you kind of read this, right? So you guys are inside of Lake Braddock Secondary School, right? Lake Braddock is inside of Burke. Burke is inside of Fairfax County. Fairfax County is inside of Virginia, and Virginia is inside of the United States of America, right? So the way this works is each subset, a smaller subset, is inside of the other one, right? So Lake Braddock is inside of Burke. Lake Braddock is also inside of Virginia. Lake Braddock is also inside the United States of America, right? But it doesn't go the other way around. Not all of Virginia is inside of Burke, Virginia, right? Not all of Fairfax County would fit in the Lake Braddock, right? So the smaller box is part of the bigger box there. This box over here would be like its own subset. This would be like Maryland. Maryland's weird. They put them off to the side. They're over there by themselves. Maryland's over here. It's not part of Virginia, but it is part of the United States of America, right? Okay, so that's kind of how you read these. We're going to make one of these for the real number system here. Okay, so this looks just like the one we just did for Lake Braddock's example, right? This is for the real number system, right? And the real number system, the smallest subset of the real number system is what is called natural numbers. And natural numbers are numbers that you naturally start counting with. Some people call them Sesame Street numbers. They'd be like 1, 2, 3, 4, ... going on forever. So positive whole numbers going to infinity. So 77 is a natural number. 1,384 is a natural number. 10,386,223 is a natural number. Any positive whole number is a natural number. All right, so natural numbers also go into our next subset, which is called whole numbers. All right, so whole numbers is the next subset. Whole numbers is the next subset. And the only difference between natural numbers and whole numbers is that whole numbers have 0. Right? And the way I remembered that when I was your guys' age learning this is that whole, 0 looks like a hole, right? Even though it's spelled differently. Whole is H-O-L-E. This is whole, W-H-O-L-E. 0 is a whole number. That's the only difference between whole number and natural number. Whole numbers include 0. All right, our next biggest subset is what's called integers. And integers is where we get our negative numbers. So we'd have like -4, -5, -16 over 2, because that would simplify to -8. -23. You guys get the point, right? So negative whole numbers would be integers. Our next subset would be what's called rational numbers. Rational numbers. And rational numbers are any number that you can write as a fraction. So a number that I can write as a fraction. So that would be like 1/2, right? Or 33%. That's a natural number. Or sorry, a rational number. What else could you guys see? You could see 0.1 repeating. You can write that as a fraction. That's 1/9. So any number you can write as a fraction is considered a rational number. Right? So just like how we did our example earlier, all natural numbers are also whole numbers. All whole numbers are also integers. All integers are also rational numbers. And all of these are all real numbers. Okay? So that breaks it down, but it doesn't go the other way around, right? So like not all integers are natural numbers, right? Integers are negative and positive whole numbers because natural numbers are part of integers. But -4 is not a natural number. That is an integer, right? So remember we had the weirdos over here off to the side, the Marylanders, those Marylander drivers, who, people who can't drive and they eat nothing but crab in Old Bay, right? They're off to the side. That on this chart is called irrational numbers. And irrational numbers are like pi. That's like the most famous example, pi. Remember, pi is 3.14159, and it keeps going on forever and ever and ever. So irrational numbers are numbers you cannot write as a fraction. So like pi, you cannot write that as a fraction, right? So it's any number, it's a decimal number that goes on forever, and you cannot write as a fraction. So that means these are non-repeating numbers. If it repeats, you can write it as a fraction. If it doesn't repeat, it's irrational and you can't write it as a fraction. Okay? So this is the real number system. Irrational numbers, even though they're weird and are off to the side, just like Marylanders, they're weird and off to the side, but they're still part of the United States. Irrational numbers are weird and off to the side, but they're still part of the real number systems. They're still real numbers. Pi is still a real number. It's just weird. It goes on forever. Okay? That is the real number system. Go ahead and fill that in your notes. Pause the video, catch up with this, and then unpause when you're done to do the next part. Okay, this says, how is a irrational number different from a rational number? Well, a rational number can be written as a fraction. It's decimals that end or repeat. Irrational numbers cannot be written as a fraction, and it's decimals that go on forever and do not repeat. So once again, like pi, right? Pi goes on forever, does not repeat, and it can't be written as a fraction. We just did perfect squares and non-perfect squares, right? Any square root that's not a perfect square, like the square root of 2 is not a perfect square, because remember, our perfect squares are 1, 4, 9, 16, 25, 36, and so on, right? Square root of 2 is not a perfect square, so that would be an irrational number. And you can see that in the calculator. Let me open that up here. Square root of 2 gives me 1.14215 right? That number goes on forever, doesn't repeat. That is not a rational number. That it's irrational. Okay? So any square root that's not a perfect square is irrational as well. Okay, so go ahead, pause the video, see if you can do this on your own. It says circle the rational numbers and underline the irrational numbers below. Go ahead, pause the video, try it on your own, unpause it when you're done to see how you did. All right, hopefully you paused the video and hopefully you did your work and hopefully you got answers that look something like this. These circled ones are rational numbers because all of these numbers can be written as a fraction. Okay? Even if it's a whole number, like 97 here is a whole number, right? That's a natural number. 97, all whole numbers or integers, we can write as a fraction by putting it over 1. 97 over 1 is the same thing as 97, so it can be written as a fraction, right? So anything that can be written as a fraction is considered a rational number. All right, so the irrational numbers are a subset of their own. We talked about that. Irrational numbers are off to the side. They're the Marylanders that are weird, right? Inside of rational numbers, there were different subsets that we saw on that Venn diagram, though. So the first subset inside the rational numbers is called integers, and integers are negative and positive whole numbers. So no fractions, no decimals, they have to be whole numbers. But it could be a fraction if it reduces or simplifies to a whole number. So like 12 over 4 would be an integer because 12 divided by 4 will give us 3. Right? It also could be like a square root, like the square root of 16. 16 is a perfect square. The square root of 16 is 4. 4 is an integer number, right? So any negative or positive whole number is considered an integer. All right, the second subset inside of rational numbers and is also inside of integers is whole numbers. Whole numbers are positive whole numbers and 0. So 17, 0, 183, the square root of 64, because the square root of 64 equals 8, right? It's perfect square. 10 over 2 would simplify to 5. Anything that is a positive whole number or 0 is considered a whole number. Now remember, whole numbers are also integers, right? But not all integers are also whole numbers. If you have a negative whole number, it would only be an integer and rational. It will not be a whole number. Whole number has to be positive whole numbers. No fractions except unless it simplifies to a whole number, and no decimals. All right? And the whole numbers also include 0. Remember I said 0 looks like a whole numbers. That's an easy way to remember it. Okay? All right, there's one last subset, and that's natural numbers. All right, the third subset inside of rational numbers, integers, and whole numbers is natural numbers. Natural numbers are positive whole numbers, counting numbers. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way in infinity, positive whole numbers, right? 4,127, 23. Any number that is a positive whole number is a natural number. So remember, natural numbers are also whole numbers. Whole numbers are also integers, and integers are also rational numbers, okay? Because they are inside of each other inside that Venn diagram, okay? But those are natural numbers. All right, so go ahead, pause the video. See if you can fill in this same Venn diagram we did in the very first page. See if you can do it from memory. Try not to look back at the first page. See if you can do it. Where would whole numbers go? Where would natural numbers go? Where are integers? Where's the irrational numbers? See if you can fill it in, okay? Pause the video, see if you can do it. Unpause it when you're done. Okay, hopefully you paused the video, hopefully you filled this in, and hopefully yours looks something like this, okay? If not, go ahead and fix your errors, make your changes, but that is the real number system. All right, this here says, what is the smallest subset these numbers would go into? So 0. If I think back to all of the subsets, what's the smallest one? Where does 0 first show up? Well, 0 first shows up in whole numbers, right? So this would be whole. That's the smallest subset it would go in. 0 is also an integer, and it's also a rational number, and it's also a real number, but the smallest subset it's in is a whole number. All right, what about -6? -6, that's a negative whole number, right? So negative whole numbers, we know, are integers. 62%. Well, if I change 62% to a decimal, that would be 0.62. We did this the other day in class. Remember, you move the decimal place 2 spots to the left, or you divide by 100. So this is a decimal that ends. It doesn't go on forever, right? So that is a rational number. -0.33333 repeating. So anytime a decimal repeats, it is also a rational number. So I'm just going to type a big R there because that's another rational number. Okay? Pi. Pi, we know, goes on forever, does not repeat, so it's irrational. Pi is irrational. 1/5, it's a fraction. That's a big hint. If it's a fraction, it's rational all the way, right? You just got to see if it can simplify it. 1/5, you can't simplify it anymore, so we know that's rational. I'm just going to put another R for rational. That's a rational number, though, all right? 1, what's the smallest subset 1 will go in? Well, 1 is a counting number for sure. That's a natural number. That's probably the first number you learn, right? So natural number, 1 is a natural number. Okay? All right, this down here is a chart, and this just kind of show you that these numbers can belong in the different subsets. All right, so square root of 6. What is the square root of 6? Is 6 a perfect square? No, it's not, right? We get this big, long, crazy decimal, and I told you guys earlier, if you have a big, long, crazy decimal and it's a square root that's not a perfect square, that's an irrational number. So that's an irrational number, but irrational numbers are also real numbers. Just like how we had Maryland off to the side, but it was still part of the United States, irrational numbers are still part of the United States. They're still real numbers. All right, square root of 4. Square root of 4 would equal 2, right? So where would 2 go? 2 is natural. It's a whole number. Whole numbers are also integers. Integers are also rational. They're not irrational. You can't be rational and irrational. You're either one or the other, right? But rational numbers are still real numbers. -6.5. Okay, this is a tricky one that happens all the time. People see this -6.5, and as soon as they see that negative, they want to think integer. Well, integers are negative whole numbers, but they're whole numbers. This is not a whole number. It's got a 0.5, right? But it's a decimal that ends, so that means I can write it as a fraction, which means that it's rational, and rational numbers are real. 1/9, that's a fraction, right? So fraction numbers are rational, and rational numbers are real. 60%, if I change that to a decimal, that would be 0.6. Remember, when you move that decimal place 2 spots, right? So 0.6, that's a decimal that ends. That's a rational number. Rational numbers are also real. All right, we have a few more here. We have 0. 0 is a whole number. Remember, looks like a whole. Whole numbers are also integers. Integers are also rational numbers. Rational numbers are also real. Cannot be irrational. Cannot be rational and irrational at the same time. Not possible. 66. 66 is a natural number. You can count the 66, right? 66 is a natural number. Natural numbers are also whole numbers. Whole numbers are also integers. Integers are also rational, and rational is also real. Cannot be irrational. -1.0. Okay, this is another one that's tricky. I see it has a decimal here, but after the decimal is a 0. So this is really the same thing as -1. It's just they added a 0.0 for some reason to try and trick you, right? So -1 is a negative whole number. So where do negative whole numbers first show up? Well, that's at integer, and it's also a rational number, and it's also a real number. Okay, so that is the real number system. The real number system is just a way to to make subsets of numbers, how to classify numbers, how to organize numbers in certain ways. The main ones you really need to know are rational versus irrational. Rational numbers you can write as a fraction. Irrational numbers you cannot write as a fraction. All right, go ahead, put your notes somewhere safe. Keep them in your binder, in your math section of your binder. Remember, we have a quiz next week. You can use your notes on the quiz, so it'd be helpful to keep that somewhere safe. All right, if you have any question, please ask a teacher, and I'll catch you next time.